Hello everyone, welcome to my channel. In this video, we're going to solve this given exponential equation similar to one of those questions given at Math Olympiad competitions. And so now, how do we solve this equation? 9 to the power of x plus 27 to the power of x equals 81 to the power of x. What we normally do solving exponential equation, there are so many ways, by the way, to solve it. But then first is by using the logarithm, but I don't think logarithm can be used in this equation. It's because if we equate the log on both sides of the equation, this left hand side will be a complex one and there's no way to solve with the logarithm. Like here, if we take the logarithm of the left hand side and the right hand side, on the right hand side we can take down the exponent x, separate the variable from the constant part, but in here there's no rule that we can separate the variable x out of the base 9 and 27 by using the logarithm or the rules of logarithm. So we're rolling out the use of logarithm to solve this exponential equation. And so now how do we solve that? Alright, so first then, we have to divide the whole equation by the first term. That means we're dividing it by 9 to the power of x. So we have 9 to the power of x divided by 9 to the power of x plus 27 to the power of x divided by 9 to the power of x equals 81 to the power of x divided by 9 to the power of x. And so now we can simplify. This cancels. So this is 1 plus second term we have 27 and the denominator is 9 power of x. We have the same exponent of x but the base are different. So based on exponent rule, if we have a to the power of m divided by b to the power of m is the same way written as a divided by b to the power of m. So we're using this rule on the second term. So now we have 27 over 9 to the power of x. Likewise, on the right hand side of the equation, 81 to the power of x divided by 9 to the power of x. We have the same. We're using the same formula. And so now let's simplify it further. So we have 1 plus 27 divided by 9 is 3, right? To the power of x equals right hand side 81 divided by 9 is 9 to the power of x. And so from here we're combining all the terms to one side of the equation starting at 9 to the power of x. So we have 9 to the power of x minus 3 to the power of x minus 1 equals 0. Do you see any relationship of the terms of this equation? Base is 3, base of 9. Can we convert base of 9 to base 3? We sure can, right? Because 3 squared is base 3 for the 9, right? So let's do that. So now we have 3 squared to the power of x minus 3 to the power of x minus 1 equals 0. And so now we have the same base, but what are we going to do next? We have this exponent 2 and exponent x outside. Do you notice something similar to both of these terms? So we can have an exponent here, 2x, right? So based on another exponent rule or exponent formula, if we have a to the power of m raised to the power of n, this can be written the same way as a to the power of n to the power of m. So if you notice that the exponents switches, right? Exponents switch. So this is what we can do on this side of the equation now. Alright, so we have 3 to the power of x is squared minus 3 to the power of x minus 1 equals 0. And so now we can clearly see the relationship of these two terms now. We have the same base with exponent x right here, second term the same way. So this turns out to be a quadratic equation, right? So now we can solve for x. So to do that, we're using substitution to represent the value of 3 to the power of x. So here let's let u be equal to 3 to the power of x. So then we can substitute this value into our equation. Instead of 3 to the power of x, we'll be using u, right? So now we have u squared minus u minus 1 equals 0. And so now this is a quadratic equation with the exponent 2, right? That's quadratic. So the best way to solve the value of u will be the use of quadratic formula, right? So from the quadratic formula, we can take the coefficients of these terms and the constant right there to the right, right? So a here is 1, b is -1, and c is -1 or -1, right? So quadratic formula, u is equal to minus b plus or minus square root of b squared minus 4 times a times c, all divided by 2a. And so all we have to do now is put in the values of a, b, and c into our equation to solve for the value of u. So now we have the value of u to be minus b is -1, so, and here minus b minus -1 plus or minus square root of b squared, that is -1 squared minus 4, and a is 1 and c is -1 divided by 2 times a is 1, 2 times 1, and this is square right there. Simplify, we have minus and minus right there, so plus, right, or positive, then plus or minus square root of -1 squared, that's 1 minus 4 times 1 times -1, so that's -4, and this is negative, this becomes positive, divided by 2 times 1 is 2. So this is now equal to 1 plus or minus square root of 5 divided by 2. So this is the value of u, 1 plus minus square root 5 divided by 2. Now if you notice, here we have two values of u. We have the positive and negative, here is square root of 5. So now, since u is a substituted variable in place of 3 to the power of x from earlier in our equation, that is u is equal to 3 to the power of x. Here, u is an exponential function which only takes a positive value of u. So this means that we're taking the positive value of square root of 5, so that is 1 plus square root of 5 divided by 2. So now let's put this in, this value of u. So we have 3 to the power of x is equal to 1 plus square root of 5 divided by 2. So now we can use the laws of logarithm to find the value of x, right? So here we take the log of both sides of the equation. So we now have log of 3 to the power of x equals to log of 1 plus square root of 5 divided by 2. And based on logarithmic exponent rule, we can take down the exponent to the front. This from the logarithm exponent formula or power rule. If we have logarithm of b to the base a, exponent c right there, take down the c to the front. So now we have c times logarithm of b base a. So we're taking the exponent to the front. So now back to our equation. We have x times logarithm of 3 equals logarithm of 1 plus square root of 5 divided by 2. Solving for x, divide both sides with log of 3. This one cancels, so we have x is equal to logarithm of 1 plus square root of 5 divided by 2 base 3. Since this is the denominator, so we can express it this way also. So this way or this way, either way. So this is now the exact value of x. And then if we use our calculator to find the value of x, so here x is approximately equal to 0.438. So to verify our answer, we substitute this value of x into our original equation. And here we have our original equation, 9 to the power of x plus 27 to the power of x equals 81 to the power of x. And we're using the value of x as approximately equal to 0.438. First term to the left, 9 to the power of x, this is approximately equal to 2.618. Then plus 27 to the power of x is approximately equal to 4.236. And lastly, 81 to the power of x is approximately equal to 6.853. Add this up on the left. So we have 8 plus 6 is 4. Carry 1. 3 plus 2 is 5. 2 plus 6 is 8. 4 plus 2 is 6. So 6.854 is approximately equal to the right hand side. This is 6.853. The difference of 0.001. Right, so this just means that the value of x is correct, approximately equal to 0.438, or the exact value of logarithm base 3 of the quantity 1 plus square root of 5 divided by 2. And so that's all for now. And for those new to my channel, I would appreciate if you can hit the like button and subscribe for more videos. I will see you in my next videos. Have a great day, everyone. Take care. Bye-bye.